fit else in here. I like the organization of the boxes as they are. Let's see if anybody messes that up. When is the next quiz? Oh, somebody just came in. That's a good question. I think at the moment I've got it for next Tuesday, which really means next Wednesday. So that's something I've been considering what to do with. Yeah, right now, right now it is set for Tuesday, and it's supposed to cover the rest of chapter 10, and we're done. We're basically done with chapter 10. So I don't see any reason why to not have it there. I like it. So just to let you guys know, just to make sure, I think I pointed this out a few times, but on Thanksgiving, I always give everybody that Wednesday off too. It won't necessarily be fully off for you because you'll have to be doing the quiz at some point. So you could do it the night before, you could do it anytime on that Wednesday. And I'll probably give you until the end of the day on Wednesday to get it done. And then you can relax a little bit over Thanksgiving. At least you're not cramming for a quiz on like Monday. So I'm going to keep it right there. All right, guys, any questions on homework stuff or general questions or? Man, somebody did not let, somebody left right when I asked that question. I don't like this guy. I'm always asking if I got a question, whatever. What's up with that? Okay. Well, here's the neat thing. If nobody has any questions, I'm going to get to chapter 11. Screw it. So section 10.8. My 9 students. 10. 11. That's so cool, man. Right when I said that. My 11 students are here with me. If you were here yesterday, then we talked about vectors. We actually finished the vector section, believe it or not. And the last thing we did was a little technical, possibly. I feel like you should probably love vectors compared to some of the other stuff we've done. Vectors are a little more contained. I have no idea if you agree with me or not. And just to remind you guys, you should probably jump into the vector section and try some problems out just before it leaks out your head. So let's kind of review a little bit. Yeah, oh, there you go. Look at that. Somebody's reading my brain. Stop doing that. Let's review a little bit what we talked about with vectors. Let me see. Okay. I know, hold on. Boom, bum, boom. Beep, boop, beep. Okay. So, I mean, the very basics of vectors, you've got your way to designate them. We normally use U, V, W. We have these freaky symbols, and so it's definitely not a point. And then I've got this here. How else could I represent that vector? What's another way I could represent that? Oh shit, I got socks on sliding. Anybody know? Does anybody remember? The components, remember the components? What were the dudes that were wearing hats? Do you remember that?
Is it I hat, J hat?
Yeah, so this could, but also negative 2I hat. Plus
Yeah, okay.
right?
I remember that now.
And let's kind of go full circle here. What the hell is I hat? What is that? Anybody remember what I hat is? It's the vector that's sitting on the which axis? It's the unit vector in the direction of the what axis?
The x-axis?
Yay. Everybody be glad Amber's here. I don't know what's everybody else here. So this would be 1, 0. And j hat's the same thing, just in the direction of the y-axis. So these are considered component vectors. They're what we build up with. We also call them a basis. We're not going to worry about the word basis too much. And so see how I can multiply that in. And then, of course, when I add these vectors together, I'm back there. So is everybody cool with that? I mean, it's got to be self-consistent. So it's got to come back to itself somehow. Okay. So there's a lot contained in this little buildup here. There's the idea of I hat, j hat. There's the idea of what those are. There's the idea of scalar multiplication of vectors. Where things got very exceptionally freaky is when we talk about multiplication of vectors. We have to be more specific. Just saying multiply vectors is not specific enough. So we got the one way we're going to talk about dot product. So the dot product of two vectors. One way to look at it is, in fact, and here's gonna review the other thing that we did. What the hell do these mean? What do these mean? Get in there. Somebody I haven't heard from yet. Is somebody else out there? What does that those symbols mean? My hand looks so tiny. Sorry. Oh man, I'm starting to go crazy. Is it just me and Amber? What happened? Is anybody else out there? Are your mics working? I like it. So it's magnitude. I love it. It is kind of related to the absolute value. It's an expansion of what the absolute value symbols actually mean. We consider them as being make something positive. They're much more than that. When we work with just scalar real numbers, that's all absolute value means. Is make it positive. But now we know the bigger story, right? So these are the magnitudes. The cosine. The other way to look at dot product, if I define U to be U1, U2, I like it, and V to be V1, V2, then U dot V would be U1, V1 plus U2, V2. Okay. And we actually analyzed why that makes sense. Does somebody remember what I hat dot I hat is? And I hat dot j hat?
Am I allowed to answer?
Go ahead.
I times I is 1 and I times j is 0.
So say dot.
Oh, sorry. I dot.
Times is too vague.
Sorry.
So I dot I is 1, I dot j is 0. I like it because the dot product reinforces things that are going in the same direction. If no component of a vector, like this vector and this vector, they have components that are going in the same direction. So their dot product will not be 0. These vectors, their dot product will be 0 because they have no component going in the direction of any other component of the other vector. Let me ask you this question real quick. Is there a vector that would So what's another way to say it? If their dot product is 0, then obviously there's a right angle there. Is there a vector that's orthogonal? Oh no, I almost said a weird word. Is there a vector whose dot product would be 0 with both of these vectors? That's too much. I'm sorry, I've gone too far. I'd have to bring in the third dimension. I'd have to have a vector coming right out of the board. There's no way to have a vector that has a 90-degree angle with both of these vectors. Okay, I've gone too far. I'm sorry. I went way conceptual there. All right. So let me get a concrete example here. If I have any vector here, -5, 2, and let's do -3, -1. I like it. So -5, 2 is like there, and -3, -1 is like, you could do it, Jeff, there. Do you see that? Just a real quick little rough sketch. It's not exactly right. So I think the angle is going to be on the shorter side, definitely smaller than 90 degrees. Let's find out. We're going to see what this angle is. Can somebody do the dot product of this for me the easy way, which is this way, where you just multiply the same components and add them up? What do you get? Is everybody?
Is it 13?
Sorry?
13.
Yes. This times this, so they're the x components. So I'm going to multiply them, 15 plus -2. So I get 13. I love it. That has to equal this. So what's the length of U? And what's the length of V? What's the length of this guy?
7.
No. Right? What's the length based on? It's based on Pythagorean theorem. It's based on distance formula. That squared plus that squared square rooted. All right, let me stop for a minute. We know this. I know this. I know if I want to figure out how long that is, and I know that this is, well, this is a bad example. I don't care. I know this is 5 and I know this is 2, not to scale. How would I figure out how long this is? 5 squared plus 2 squared, take a square root, wouldn't I? Isn't that? Please let some of this be simple. Please let some of this be simple. Like I try to explain to you, vectors is kind of reusing a bunch of stuff we've already done. Let that be nice. It's the symbols that are different to us. And the dot product is definitely new, but it's using stuff that we already know. All right.
Are we going to have to graph vectors?
Possibly, yeah, of course.
Can you show us how to do that, please?
Well, how would you graph? Look what I just did. Do you understand what the hell I just did? So how do I graph this vector? Well, what does it mean? What does that name mean? If it starts at the origin, what point does it terminate at? How did it get that name? The name of a vector is the coordinates of the point it stops at if it starts at the origin. Do you guys remember that? So if I have a vector that starts at the origin and it goes to the point A, B, the name of the vector is A, B. If I pick that vector up and move it, its name is still A, B. It just doesn't start at the origin anymore. And then I have to take a difference to figure those out. All right. All right. Let me see. I'm going to take this away. We're not done with this problem, but I feel like we can't continue with this problem yet. I really, really need you guys to come with me. Get the here. You got to get the stuff that's not too crazy. So again, so if I have a vector here and it's from the point, I'm not even going to put freaking scale. It's from the point 1, 4 to 6, 2. Can you figure out what its name would be? This is one of the first things we did with vectors. And again, how do you determine what its name is going to be? You have to somehow move that to the origin. So how do you move that to the origin? Well, you got to move it back 1, which means that's going to come back 1. Which means that's going to become what?
5.
Yes. All right. So it's 6 minus 1. So, of course, and then it's got to go down 4, which means that's going to go down 4, which means that's going to be 2 minus 4. So it's end minus beginning. 6 minus 1, 2 minus 4. So it's going to be 5, negative 2. And sure enough, if I move this to here, this is going to move to here, and that looks like it could be 5, negative 2. And again, my scale sucks here, but oh well. That's one of the first things we did. So that is the vector I could designate as 5, negative 2. What that really means, and you don't even have to think of it as moving this down. How much over do I have to go and how much down do I have to go to get here? Don't I have to move over 5 to go from 1 to 6? 5. Don't I have to go down 2 to go from 4 to 2? Down 2. So if you don't like the idea of moving it to the origin, you can just think about it like, how do I go over there? How do I get from here to here? That's the name of the vector. Is that okay by itself? Is that all right? Okay. Now, what would the length of this vector be? Well, isn't this side 5? And isn't this side 2? The length of it, right?
Mm-hmm.
What's the length of the vector? Well, freaking square root of 5 squared plus 2 squared, right? Right? Is everybody with me?
Mm-hmm.
Old news, old news. That's how I got freaking square root of 29, freaking. I know it's a negative 5 here because I squared it. So square root of negative 5 squared plus 2 squared, square root of 29. That's the length of that vector. What's the length of this vector?
Square root of 10.
Yeah, 3 squared, 9 plus 1 squared, 10. Like. So finding lengths of vectors really is just finding r. You know x, you know y. Isn't this x? Isn't this y? What's r? Square root of x squared plus y squared. See, it's built on stuff we've done. Now, just to remind you guys, here's what we had just a minute ago. This thing we actually proved last class. We proved this for the dot product. We also proved the short way to do it, right? So why is there this way to do it? Because sometimes this way is easier, to be honest. And also, if I look at it both ways, I can figure out what the angle is between them. I can solve that for theta. I can figure out what angle is between any freaking vectors I draw. I can figure out the angle between them like this. So the angle will be the inverse cosine of 13 divided by square root of 290. And for my little picture here, I would guess that it's maybe 34 degrees. I don't know. I'm probably really far off because my picture sucks. Oh, okay, not too bad. I can live with that. I really want you guys, I really want you guys to be like, holy shit, that's pretty cool. Any vectors you draw, just draw some arbitrary vectors. You could figure out what the angle is between them by doing this. If you know what this vector is and you know what this vector is, you can just do the steps we used here. Do the dot product the easy way, do the dot product the hard way, solve for theta. That's pretty cool. It just is. All right. Oh, let me do one more thing with this. What if the two vectors were this? All right. How's that compared to these vectors? That's the same. What did I do here? I just doubled it. Should the angle change between them if I just make one of them longer?
No.
The angle should be the same, right? Well, let's see real quick. Let's see. U dot V, the easy way, will be 30 minus 4, 26. Is that cool? Double that. Holy shit. Huh, interesting. All right. And that should equal, I know the length of this dude is square root of 29. The length of this dude should be easy, but let's see. Let's go the hard way. Square root of 36 plus 4 is 40, which is twice square root of 10, which only makes sense because I made it twice as long. Right? Isn't it twice as long as it used to be? Nothing amazing there. Somebody asked me, can I show a super difficult one? I don't know. Yeah. Is it one you have to worry about? I don't know. All right. So now what do I got to get? Do you see how I shouldn't even have to do any more work? I really want you guys to see how this is kind of trivial now. If I divide by 2, doesn't it become the same thing? And of course, I'm going to get the same angle. Okay, so that wasn't amazing, but I want to show you that it is self-consistent. If I make one of them long, the angle better not change, Jeff. If it does, we get through all this shit. Oh, man, it's the same angle. We got to keep it. Damn it. So the person asking me for a super difficult one, do you know what you're asking for? I don't know what you're asking for.
Okay, so like I feel like problems you show, like I understand them, and then problems on the homework, I understand them, and then when it comes to the test, there's like really hard problems that I feel like I haven't been exposed to. And so I just want to be exposed to like more difficult problems.
Well, I try not to. If you could show me an example in a quiz of where that has happened, I could figure out more what you mean.
Like the last problem on the quiz we just took.
Oh, okay. Let me remind myself what that was. Let me see if I agree that it was freaky. Well, I see. Let's see. Now I'm curious about it. Everybody just hang out. Oh, wait a minute. Well, let's see. I don't know which version you had. You mean the actual very last problem?
Yeah, it was like 6B, I think.
Yeah, let me see. Yeah, they don't look, I don't understand. All right, I'm sorry. I don't mean to make you feel bad, but let me see. There's another version. Let me see if I can see it. No, that's the same one. Oh, yeah, shit. Well, the ones I'm looking at don't look too bad. I don't know. Is it possible I made one version with something a little too weird? It's always possible. I hate that I have to make multiple versions of quizzes because that does open the door to me making something harder than I wanted to. No. Okay. So I feel like, let me keep an eye on this too. I feel like I might be able to address your specific question. Well, no, I can't without giving too much away. I'll tell you this much at least. And then if you want to, you can try to stay after class and I can talk to you one-on-one because I don't want to give anything away because there's a lot of people that still need to take that quiz. Everything in that problem was directly something you know. Yeah. That's all I'll say. I can't say more than that right now. But in general, if you feel like there's something on a quiz that, just let me know at the time. Very often you're looking at it wrong, or maybe I did try to push you a little bit on one problem, right? I feel like I reserve the right to do that. That problem, no, I disagree with you. That problem is actually pretty straightforward. And if you can hang out and I can show you why it was. All right. So you do need to memorize the process of dot product both ways, the easy way and the hard way. And I say the hard way, but it's not, that isn't hard. Give me a break. All right. That I think is that's the newest idea in that whole section is the dot product. The idea that it exists and the idea that it's not the only way that I can multiply two vectors. Remember what I said? One way to multiply vectors ends up with a number. The other way to multiply two vectors ends up with a vector. I like it. Okay. So what we're about to get into, I'm about to leave chapter 10 behind. And we're about to get into something I think you should completely be overjoyed that we're about to get into. And that is just solving systems of equations. So can somebody help me out? Can you guys tell me how you would solve this system of equations here? Maybe I should make one that works. Would that be good if I do that? Sure. Okay. Can somebody tell me the real quick, easy way to solve this system of equations?
You could just add them together.
Hell yeah. Can I always just add any problem system of equations together and it's going to do something good for me? No. Right? Why is this good to add together? Because what do the Y's just want to do? They just want to die. Right? They're like Meeseeks. Existence is pain. Right? Existence is torture. So let's let them do their thing and die so I can add these. Is anybody having trouble the fact that I can add equations together? Do you guys remember doing this? Has anybody ever wondered why the shit am I allowed to just add equations together? You freaky ass math people. Has that thought ever gone across your brain? Or are you all cool with this? Let me know. And you're all like, don't let him know. What's going on? Okay, all right. So then divide by 7, you get 3, and I was going to tell you why it was okay, but you don't want to know. And then if you put a 3 back in, that's 15. Subtract 15, you get y is 1. Whoop-de-doo. So I took section 11.1 out because that's section 11.1. I am desperately needing to believe you can do that, right? And then there's substitution method. Do you guys remember substitution method? No? So if you have something like, what do you got, Jeff? Another one? I've got to make another one. All right, I don't know. 3x plus 5y equals, you could do it, buddy. I don't know. Okay. And then, what did I just say that was? Oh, yeah. And then x equals negative, no, negative 2x equals y, I think. I think so. Yes, okay. So this, let me see what it is, okay. This second equation tells me what y is. So I can just plug it in. Why would I write the first equation 3x plus 5 times y when I know what y is? Right? Not a smart man, Jenny, but I know what y is. All right. Does that look familiar to you guys, or does it not look familiar to anybody? Let me know. All right. And then you get 3x minus 10x equals -7. You get -7x is -7, x is 1, and then y is -2 times x, so y is -2. And you can write the answer as a point, because that point is where these lines would meet if I graphed the lines. Oh, hell yeah. Somebody's asking about matrices. Yes, we're going to get to matrices. There is no spoon. Good old matrix. Nice. And you'll see, you'll get some motivation as to why matrices are good right now. When we do some problems without matrices. So, what do you guys think about this problem here? Already you love it, don't you? I know you do. You already completely enjoy these problems. Let me see. Why are you going to make it hard on yourself, Jeff? Let me write something here. I got to start with the answer so I can make something that works. Let's see. Let me. Okay, this is going to be exciting, everybody. Let's see if Jeff can make a problem that works. Why do that to yourself? Okay, so this will be that should be good. Let's see. Let me double check. That's 3, 5. Okay. That should come out nice. So the way I created this problem was I started with values for these three, and then I just made something and then figured out what they would equal, made something and figured out what they would, blah, blah, blah. That's how you can make a problem with a good answer and not fractional answers. What the shit do I do with this? What the shit? It was so much easier when I just had two variables. I could just kill one of them and I'd be almost done. What? What? Let's talk about this graphically for a second, right? A system of equations with two variables are a line and a line, and the answers where they meet, and maybe they're parallel, there's no answer, right? Or maybe they're the same line and there's an infinite answers. Do you guys remember that at all? What sucks about not being in a room with you is that I would say this, it lives in how many dimensions? 3. Yeah. So this could be like the ceiling. This is the equation of a plane. This is the equation of a plane. So this could be the equation of the ceiling. This could be the equation of the back wall. And this could be the equation of that wall. So the answer is going to be the corner point where they all meet. All stuff you can't see. That's too bad. I'm not going to give you a tour of my house. My little house. But that's geometrically what's happening. So there's a ton more ways for this to not have an answer. You can have two planes be parallel. You can have two planes meet fine, and the third plane doesn't really like either one of those. There's so many ways for this to not have a solution. But we know this one does. Does anyone have a suggestion as to what to do with this thing?
I don't know. The first thing I would do would be solve for z.
Oh, I see. Okay. So you could try some multi-level substitution method. Is that what you're thinking?
Yeah.
I like it. At the same time, I hate it. So, that's a possible way to do this. What very often happens with what you're going to try to do is you get all these fractions that you should be able to work with. I'm damn good at math. I'm not going to work the fractions if I don't have to, right? Because that's just one more place for me, a human, to make stupid mistakes. Nothing wrong with what you're suggesting, but very often it's the harder way to go. The easier way to go is elimination. And that's what actually leads into the purpose of matrices. So it's kind of like a double reason why we go that way. It helps us with what we're going to do anyway, and it's easier. It's a twofer. So the idea is I have to kill a letter twice. I have to pick a letter and kill it twice. Just so if I kill Z twice, don't I get something with X and Y and another thing with X and Y? And then I can kill Y or kill X. So it's like the domino, it's like the, what do you call it? Divide and conquer? There, something like that. Do you guys, is everybody okay? You want to kill Z? Anybody like thinks Z looks shifty? Z's a little sus. So we gotta blow him out the air, whatever the shit. I don't know. I've never even played the game. I just seen some stupid memes. I'll get over it. All my free time, I'm gonna sit down and play whatever it's called. I can't remember. All right. So if I want to kill Z, what's the most direct way to kill Z once? Amongst all three of these. Does Z just naturally die between two of these?
1 and 3.
Yes, so if I do 1 plus 3, I get 4. Good job, Jeff. Now, the reason I'm writing it like this, even if I did 1 plus 2, I would still say equals 4. It equals the fourth equation. You guys with me? So the first equation plus the third equation equals a new fourth equation. And what do I get? 4x minus y, z's die, z's dead, baby. And then 11 and 2 is 13. Is there another way to kill Z? Not directly. You got to do something, don't you? What's the next easiest way to kill Z? I have to use different pair of equations. I can't use 1 and 3 again because I'll get the same stupid equation.
You could double equation.
I'm sorry, go ahead. Double equation 1.
Yeah, double equation 1 and then add it to equation 2.
Yeah, so let me write twice 1 here. And then I'll do twice 1 plus 2, and that'll be my fifth equation. Do you see how this doesn't have, all right, I hope you guys are cool with that. So then I get 4x minus y. Oh, do I get this? Oh, no, I don't. This makes me very concerned. Is that true, Jeff? No, plus y, thank God. If I could just do math, I could be a better math teacher, I know. 22 and 5 is 27. Is everybody with me? I got very concerned there for a minute. Can you guys understand why it would have been bad? 4x minus y equals a different number. There would have been no solution. That's not what I want to have happen right now. And now this is beautiful. This does not always happen. Don't get too excited, but can't I kill y now? So I got z dead, because what's the main problem with this? Too many variables. Let's kill one of them. Yay. Oh shit, we got to kill them again. Yay. And now I've got a simple 2-variable system of equations. If I add these up, I get 8x equals, holy shit, yay. I don't know, I'm happy I made one that worked, at least so far. Is everybody understanding? No? All right, so you get x is 5. And then what starts from there is what I call dominoes, right? Not the horrible pizza, but I call it dominoes because you start to fall back. From x, you can figure out what y is. And once you got x and y, you can figure out what z is. So I'm going to use this equation because it's easy to solve for y. I get 4 times 5 plus y is 27. So I get y is 7. Is that cool? And then the easiest equation to use to get z is the first one. I'll get x is 5, y is 7, plus z is 11. I get z is -1. And this would be a 3-dimensional point, 5, 7, -1. That's the coordinates of the point where all three planes meet. So it's very possible to have no solution. And it's also very possible to have infinite solutions with these. So let me show you this. I did put up a handout just in case you suck at taking notes. All right, you know who you are. So let's see, let me show you this. So if you go here, let's see, and you go to unit. Oh shit, oh good, I collapsed them all. See, you can collapse all these so you can get through here quicker. Go to unit 11, system of three equations handout. Pop. So it has a little problem, it goes to the problem, it explains all the steps, but this is, again, you really, really should just be like, please, Jeff, give me a lot of this kind of thing. This is so, you can sink your teeth into this a lot easier than you can some of this amorphous, verify this identity. Oh shit, there's just no knowing. This is so recipe-ish that it kind of makes me sick, but you should appreciate the fact that it's recipe-ish. Okay. So I'm going to push my luck here and see if I can cram a few more ideas in your brain, because that's all I'm going to say about that section. That's pretty straightforward. You should have done that in your Math 110 or equivalent class. Here's something you definitely did not do in your Math 110 or equivalent class. Let me see. Actually, the first problem we'll do is what I call a motivation problem. And you're all like, dude, I have a motivation problem. No. So here's, let me just say recall, just to let you know, this is nothing new. This is shit you should be able to do. Can you very quickly, please, add these two things, together? Let me make it, well, if it's already too late, Jeff, it's all right. We'll do two of these. I made this a little bit freakier than I wanted to. It's not too bad, right? Are you guys understanding what's happening? What do you have to get first?
And make the denominators the same.
You all see, I love it. So this guy's x plus 1, x minus 1. So he needs an x minus 1. So you get 3x squared minus 3x plus 1 over x squared minus 1. Is that cool? You guys all right? And then you could, if you could factor the top, you could see if this fact cancels, but it doesn't. What about this here? What do you got, Jeff? Yeah, let's do one that's a little bit less freakadelic. Yeah, just a little, just this little tiny dude here. I like it. I see. So here's something really nifty. I mean, this is not that part of a problem. You guys should be done. This is somewhere you could use a modified cross multiplication. Whenever the bottoms have nothing in common, this times this, with this times this on the bottom. So 5x plus 5 3x, so that'll be 8x, 5x plus 5, 3x minus 21. So 5 minus 21 is minus 16 over x minus 7. Is that right? Right, you don't have to do that way. You can give this guy his x plus 1, that's what he needs. And you can give this guy his x minus 7, that's what he needs. So there's the bottom. And then you get your 5x and your 3x, and you get your 5 and your negative 21. All right, how we doing out there? Those are beautiful. Those are nice. Those are not what we're doing because those are old shit. This is just a quick reminder. What I want you to notice is I should be able to find a way. If somebody gave me this, I should be able to break them back up. Does that sound interesting? It actually doesn't matter. We're going to do it either way. So here's what I mean. Let me see if you guys can get this idea. So let's say somebody gives me this fraction here. I don't know. Yeah, this is making something not too freaky. Sure, I like it. Can somebody tell me if this came from the addition of two fractions, what must have been on the bottom of them?
X plus 2 and x minus 2.
I like it. And on the top, since this is not reducible, neither one of these can be reducible either. So the top has to be one less degree than the bottom. So the top has to be just a number. That was a long way to go for that. Do you know what the number is that goes up here? No, that's the problem. That's what we're trying to figure out. But I can't call it x because x represents any number for this. So I actually give it, this is sort of like a parameter. I'm sorry I said that. It has nothing to do with parametric, but it is that kind of next level up. It is not a variable. It is a value in its own right that makes this thing work. Oh, this is no longer recall. This is new shit. Okay. So now watch. This is really, 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 really cool. It just is. I remember when I first learned this and I'm like, I love this shit. And then people next to me were like, you're definitely weird. If I multiply both sides by this, let me see if you guys, and wouldn't that be multiplying by x plus 2, x minus 2? I am allowed to do that, am I not? As long as x is not 2 or negative 2, but it's already assumed that x is not 2 or negative 2, right? Just by writing it, it's assumed that it can't be. So what happens here? Right, the x plus 2 dies. So what I say to myself is a picks up an x minus 2 and b picks up an x plus 2. They always pick up what they didn't already have because whatever they already had dies. And now you could say to yourself, okay, Jeff, how does that shit help? All right, so here's the next amazingly cool thing. Let me show you this way first, because this is the by the book way to do this. And then I'll show you an alternate method that sometimes doesn't work, but when it does work, it kicks so much ass. So let me show you the by the book way to do this. That's amazing so far, right? Wow. And then I can get my X shit together. Let me see if you guys are cool with this. And then I can get my number shit together. I don't know why I made it so weird. Let me do it this way, just so it's not too weird. I don't have to do that at all. It doesn't matter, Jeff. It doesn't matter. So can somebody tell me What must be true about a plus b in order for this to be true? What do you think? What a plus b is the coefficient of what? X. So what must a plus b be if this equality is to hold?
4.
4. I love it. And I see you, Emily. Thank you. So a plus b must be 4. And what must, I have no idea why I wrote like that. It's no good. What must 2b minus 2a equal?
-1.
-1. So the x stuff has to equal the coefficient of the x. The number stuff has to equal the number. That's insane. And then I get a little system of equations. Oh, where did I leave off? Oh, yeah, -1. So let me bring this over here. So if I make this 2a plus 2b equals 8, then I can just add these things together and kill my a and my I'm sorry, what's going to die? Yeah, my a. Now it kind of makes sense about, okay, what did this have to do with systems of, oh shit. So then these die. This is 4b equals 7. So then b is 7/4. Become a b. So then a plus b is 4. So a must be 4 minus 7/4. So 16/4 minus 7/4 is 9/4. So b is 7/4. And a is 9/4. So what's the answer then? There's the weird thing. That's not the answer. The answer is what the shit this is. So if you break this up, you get 9/4 x plus 2. Let's see, plus 7/4 x minus 2. So with that, just replaced a with 9/4 and I replaced b with 7/4. So what we call this method, we call it equating coefficients. That's such a very, oh, wow, how creative of a name. Equate the coefficients. But does anyone find this at all intriguing, even in the slide? You don't have to humor me. You can totally be like, it's just more math shit, Jeff. To me, this is really, 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 really amazing shit when I first learned this. I mean, it's so cool. Maybe it might be just me. Let's try one more problem. Oh yeah, we got time. Let's try one more of these. And then I'll show you the handout related to this and show you what we're working our way up towards. So anybody, I'm sorry, let me let you finish copying that. So everybody got all that? Uh-oh, somebody's got, don't use all the Zoom. Oh, I see. Thank you. Somebody's got a thumbs up. I have no idea what that's from right now. All right, here we go. So what about this? Here's something freaky. What if I have, what do you got, Jeff? I don't know. Yeah. Now, what's weird about this is do you understand why you can't say this must have come from a over x minus 1 plus b over x minus 1? Do you see why that's pure bullshit? Wouldn't this just be a plus b over x minus 1? Where the hell would that have come from? Do you guys see that? So, let me see if I can say this correctly. If I have a repeated root, remember multiplicities? Oh shit, if I have a multiplicity, if I have a repeated root, I actually have to break it up like this because this covers the possible places that this fraction could have come from. Notice this too, this is huge. The The piece that's repeated, what degree is it? This piece. What year is it? What degree is this? X minus 1. No. What degree is x minus 1?
Just
X 1. Right. There is a first degree dude that shows up twice, correct? The top thing must always be 1 degree below the bottom thing. So I really want that to make sense why that's not included, because this is just x minus 1, x minus 1. It's 1 degree. So the top has got to be just the number. This is going to become very important when the bottoms get even freakier. So this is going to be a over x minus 1 plus b over x minus 1 squared. And then you do the same thing. Oh, I forgot to show you the other method. Damn it. I'll do it here, but it's not going to go as far here. Damn it. So that's the first step. Write down everything here that could have led to this. That's the point of that side. If it turns out I don't need this guy, there will be a 0. A will equal 0 as I do the work. So the whole idea is to write all the possible shit that could have went into making this guy. And then anything I didn't need, math is going to make it 0 for me. Thank you, math. So now I just multiply both sides by x minus 1 squared. And what's neat is this guy just completely disappears, and this guy just picks up one of them, right? So I get 4x plus 2 equals a times x minus 1 plus b. So 4x plus 2 equals ax minus a plus b. So then what must a equal? This is so cool.
4.
A must be 4. I love it. Just equating coefficients. That's so awesome. And then what's negative a plus b have to be?
2.
2. So therefore, negative 4 plus b equals 2. B would equal 6. That's so awesome. That came out so nice. So therefore, this fraction can be, you ready for this? Can be decomposed into these parts. This is called partial fraction decomposition. Little zombie fractions, right? Running around. So this can be decomposed as 4 over x minus 1, right? Because that's a over x minus 1 plus 6 over x minus 1 squared. And if you want to, you can actually get LCD and show that these are equal to each other. Yeah, let me show you the handout. I wish I would have remembered on that first problem. It's a little more, what do you call it? Nifty. Sure. This time of day, that's as good as I can do with my work. I got the best words. I'm so happy. Sorry, I'm not going to start talking about he, she shall not be named. Here we go. So let me show you this. So that's that handout. And then right below that handout is a handout called partial fractions. And it goes further than we've gone so far. So I would think that you can understand that we've only touched the surface. So on this first problem, here's an example problem. You can see how it's going exactly like we're used to. But then you see this little asterisk. And this is we might do some more like this next time. Right here, I really want this. This is so beautiful. I love this, but it doesn't always work all the way. But sometimes it helps. It's hard to say this without some more examples. All right, is everybody cool with the first couple of steps here, right? I broke the bottom up into parts. I put the a and the b on top. I multiplied both sides. So the a picked up an x minus 4. The b picked up an x plus 2. Is that cool so far? And then I could do just like we did earlier, or I can pick values for x, because what can x be? What can x be in here? Any damn thing except -2 and 4. But here's what's cool. If I do pick 4 in this, can x be 4 in this? Yes. Look what happens. Why did I pick 4? What, doesn't the a piece die? If I make x 4, what's -4 minus 14? -18. What's b times 4 plus 2? 6b. And then I can solve for b. Bam! And then I do the same thing. What's going to make the b piece die? If I make x -2. If x is -2, I get -6. I'm sorry. -2 is 2 minus 14 is -12. There you go, Jeff. Past Jeff was right. And then if I make x -2, I get -6a. All right. Anyways, you don't have to know this method at all. I'm just hopeful some of you guys realize this is really, 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 really cool. And sometimes it will not help at all, but most of the time, it at least helps a bit. Oh, we'll see when we get into some harder problems, like on this one. Well, this one is nice, but it won't go all the way because there's no x control here. So this is kind of a silly example because it's almost too easy a problem anyway. When the denominators start getting worse and there's more repeated shit and there's irreducible shit, look further down, look further down, look further down. Oh, okay. Now we're talking about some shit. Then it's not going to help all the way, but it almost always gives me one thing at the beginning, and then I have less unknowns. And again, until we do some more examples, that doesn't make the most sense. But this alternate method always helps out. Either it completely finishes it, or it gives me 1 or 2 values, and then the rest I got to figure out this way. All right. I think it's enough, Matt. That's plenty. So that's pretty good. So that's section 11.2 and 11.4, if I remember correctly, because I threw out, I threw out 11.1 and 11.3. I like it. So not too bad. We're pretty good. Yay, go us. All right. So don't forget that quiz if you haven't started it yet. Let me know if you need to hang out afterwards. Otherwise, you are free to go.
Thank you.
Bye. Thank you.
Thanks for showing up.
Yeah, why are there so few people now?
Dude, there are more people than this.
Has anyone dropped out yet? I mean, I guess some people.
Many have. We have 20, I think the last time I looked, we have 28.
What did we start with?
40 something.
Jeez.
Yeah.
Well,
It's sort of understandable. I mean, this is a lot of units and people think I'm mean with the homework, but it's twice as much homework as a 3-unit course because it's a 6-unit course.
yeah.
And people kind of forget that. And it can't be easy in this format.
I know. It seems pretty fair for 6 units to me. I don't know.
That's what I thought. I cut the homework down a bit than what I would normally do in a non-pandemic time. And people kind of would laugh about that, but it's true. And again, it's a 6-unit course. So, but you know, people have different things going on. Several people had to drop for COVID reasons. Like they had a family member get COVID and so that I can understand. But a lot of people just dropped because they couldn't keep up. Yeah.
Jeez. Well, okay then. See you.
Take care.
Thanks.